Hello, everyone, and thank you so much for joining us for another VES-Artex Academy webinar. My name is Annie, and I'm going to be serving as your host today. I'm very excited to be joined by Peter Manneke, who's going to be walking us through the presentation today on why you should stress about heat stress. Before we go ahead and get started, just one housekeeping item. We will be taking questions throughout the presentation. So if you have a question based on Peter's presentation, please type it into the Q&A panel, which is at the bottom of your screen, and then we will address them at the end of the presentation. With that, the floor is yours, Peter.
Yes, hi, thank you, Annie, and thank you all for joining us. I appreciate your giving up your valuable time to listen to this webinar and this presentation. And I also thank those who will watch it afterwards and not will able to see it live. So a little bit about me. My name is Peter Manneke. I've been working in the agriculture and dairy industry for most of my adult life. Born and raised in a small village surrounded by cows and horses, worked at the dairy farm and worked in the dairy industry for many years, and for the last couple of years at VES-Artex, with focus on cow comfort and especially cow cooling and ventilation. With that, let's first of all define what we mean with heat stress. So we hear more and more about heat stress lately, and I'm not going to go into the discussion about climate change or if this is something like a cycle, but heat stress is prevalent, and we see it around us all the time, even in countries which in the past we didn't think we would have heat stress. We see heat stress. And heat stress is basically any combination of a temperature, humidity, radiation, and wind producing conditions higher than the animal's thermal neutral zone, causing the animal's body temperature to begin to rise. Now, this is a little bit breed dependent, but for most cows, they feel more comfortable with cold, around freezing temperature, than with heat. And when we go to look at the data and we see what's happened in the last couple of years, we can see here from this graph quite clearly. This is the Royal Institute of Meteorology Institute in the Benelux. And we can see there's a constant climb as of the beginning of last century. And especially in the last, I don't know, since the 1950s, 60s, we see a sharp climb further up. And this indicates that the temperature worldwide, but especially here in Northern Europe, has gone up by almost 2 degrees on average, which is, pretty significant. If we look at the weather in Northern Europe, we can see that we measure almost 15% of the year where cows are on heat stress. Now, mild heat stress causes about a milk loss of about a kilo and a half. More moderate heat stress, you can lose up to 3 kilos per day per cow. And if you go to severe, it goes even higher. So these are pretty significant. I don't know if you noticed, but Annie will show a couple of questions, a poll throughout the presentation. There'll be 3 questions in total. So this one is about the core body temperature of a cow. So please feel free to answer. So a human produces roughly the energy of each hour of a 100-watt light bulb. A cow does about 16 100-watt light bulbs per hour. So a cow produces a lot more heat and energy than we do. And the question is, how does a cow deal with this energy? We have the respiratory system, where the cow can breathe faster, like you see with other animals, like dogs. And just as a fun fact, did you know that a horse requires about 49 liters of oxygen per minute where a cow requires about 250 liters of oxygen per minute, which means that a cow requires about 250% more oxygen per minute than a horse just standing still or laying down. Okay, huge difference. In addition, the oxygen, and now you see the milliliters, the issue is that a cow needs to breathe this 250% more oxygen with only 30% of the lung capacity that of a horse. So a cow has only 30% of the lung capacity of a horse, and she needs to breathe 250% more oxygen, which is a task. Okay, so here we see it again. And here I can go to respiratory system, and you can see here the cow's lungs. So to put it into perspective, asking a cow to produce milk when they're in heat stress is like asking a human to make a 6-course meal for 20 people directly after running a marathon. Okay. So what does a cow do to get rid of the heat? So what is the heat abatement method she can use? So this cow, she doesn't need to retain all these 16 light bulbs worth of energy, especially not during the hot summer months. So transferring the heat is definitely a priority for the cow. And there are three major ways in which a cow can transfer the heat of herself. Now, the first is convection, where the heat is expelled through the respiratory system, sweating, and excrements. The second is conduction. So heat is transferred from the cow to material around the cow. The cow is able to touch, such as the bedding, flooring, bed rails, gates, etc., anything which is cooler than the body. And the third is radiation, where heat is transferred into the environment the cow is in. So normally that means cooler air, wind, whatever it may be. So how exactly does a cow do that? Some heat abatement strategies and methods we can implement to help cows get rid and stay cool is the following. We can create air velocity for the cow. We can soak all the way to the skin with water. And this basically is an alternative or another way of sweating. So this helps the cow sweat. We can cool the ambient air with high pressure fogging if the local climate supports this. So when it's too wet or too humid, it's not advisable because you simply create a sauna. We can provide shade for the cow and roof insulation. We can limit stock density. We can provide adequate clean water space and achieve a uniform airflow. Achieve optimal airspeed and maintain bedding placement and dryness. These are all very important and will help the cow get rid of the extra heat she has. So research have shown that the thermoneutral zone, and again, this is breed dependent, but in general, is the temperature range where cows are the healthiest and most productive. So this range extends from somewhere -6 Celsius to up to 18-21 degrees Celsius at the top and the highest. So increasing time spent inside this temperature range can maintain and improve the cow's health and well-being. Using the previous listed heat abatement strategies can help create or extend the thermoneutral zone. So there's a way that we can measure heat stress with THI, and if you want to know, this is the formula. But basically what THI means is temperature humidity index. So we create an index which shows on the left the temperature, and on the top here we see the humidity. And the combination of these get a number, which is the result of this formula here. And as long as the cow is in the white, she's safe. She feels fine. It starts to get a little bit tricky when a cow gets into the yellow. So 68 is sort of the threshold. And then you go from yellow to orange to red. And when you go and hit purple or beyond, there's not much you can do anymore. The other thing is, you don't have to have really fancy equipment in the farm to see if a cow is in heat stress. And one cow is different from the other. So you can have a high yielding cow, which is a peak of a yield, or even worse, a dry cow, which is about to give birth. She will feel the heat stress much quicker than, you know, a low yielding cow or a calf. And the best way to see this is just count how many times a minute the cow breathes. And all you need is about 15 seconds. So if in those 15 seconds you see the cow breathe more than 15 times, so more than once a second, you know this cow is already struggling to get rid of her extra energy. And that's always a good thing. When I go into a farm, one of the first things I do is, how much does the cow breathe? Is she panting or is she just breathing normally? And what we see as a result is when the PHI increases, and this is no news to anyone, the milk production decreases. And this is a table and a study done by, I probably mispronounced this, but Bernabouki and others in 2010 already, where we see that, you know, the milk production goes down. Most of this have been done, and we can see that after 17 hours of exposure to an average PHI of 68, we lose quite a lot of milk already in the milk yield. So this data is collected by Collier and others in 2011, which supports the previous conclusion. There's another study done. This is from Hetler, West, and McGilliard. And they did some research and they saw what effect the environmental temperature has on the amount of dry matter consumed by cows, which obviously is the opposite. So when the temperature goes up, the dry matter intake goes down. And I'll come back to this in a minute. So last but not least, this is the last graph, scientific graph, and this shows that the feed efficiency is optimized in this thermoneutral zone, which would always make sense. So I talked earlier about how you can see heat stress, and I talked about panting and breathing. But when it gets worse, there's obvious signs you can see in the farm, and one of those is perching. So in the following slides, I'll show some examples of cow behavior when they're experiencing heat stress. So when these behaviors are occurring frequently, heat abatement strategies must be immediately delivered. So this image shows cows perching with the front legs are positioned on the bed while the back legs remain in the alley. So they're trying to increase the surface area for heat to radiate off of them. So as you know, that at the belly of a cow, there's some big veins close to the skin. With the air moving past underneath, she tries to get rid of this extra heat. Here's another example of alley standing. So this cow is engaged in what we call, more or less the same. She's trying to, with this behavior, get more air movement and maybe even shade, if it's more shade in the alley than in the bedding. Another example is manure splatter on the legs. So the reason why we see this is there could be a few reasons. If you're soaking, you will get more wet manure. Cows will like to look for manure, especially wet manure, because it helps to cool down. And the other last slide I will show you, or second last slide I will show you, is standing in water. So this example shows what the cow is trying to do. So the blood vessels in the cow are predominantly in the hooves, where with very little insulation. So there's hardly any insulation where the hooves are. So by putting her hooves and the lower legs in water, she helps cool the blood flow. But unfortunately, this is not good for the other cows. It contaminates the drinking water, and you have to replace the water regularly, or put something around the water so it prevents the cows from getting in there. The last example is bunching. So bunching is a result of cows competing for resources. This could be water, it could be shade, it could be wind, it could be anything. Bunching is also a natural response for stress. So cows in heat stress, they behave like any stress for that matter. And they bunch together, which creates the opposite effect, of course, because when cows are close together, they share the heat with each other, and it doesn't help them. So this is another, telltale sign of what cows will do when they're in stress. So the next question is, how does this affect the health of a cow in heat stress? So if you're aware of this, a 1 degree Celsius increase in the uterine temperature 1 day post-insemination can reduce the conception rate by 7%. A cow's reproductive abilities are influenced beginning at about 39 degrees Celsius. So, for example, a mud roof without insulation adds roughly 5.5 degrees Celsius by convection to the building environment, which is pretty big. So one of the most significant consequences of heat stress is the experience by the reproductive system, not just by milk loss. So at the forefront, increased abortion rates and increased twinning. Heat stress also complicates the mother's health and diverts her energy from supporting the embryo development. The barn environment is challenged with heat stress as cow flow is compromised, and replacement flow can be affected 2 years post the heat stress event, if not more than 2 years. This culminates in timely complications and overall reduced profits, as each cow requires additional funds to re-establish their health. Heat stress impacts the current and future health of a cow. So reducing the impact of heat stress increases each cow's health and your bottom line. And one good example of that is already at the embryo development. So as mentioned before, heat stress diverts the mother's energy from supporting embryo development. And this is seen particularly in the early days. So the first day after conception, the single cell and the 4-cell embryotic stages are the most susceptible for heat stress. And as a result of this, what we'll see, and this is studied by Castiel, Espirito and others, they see and they've proven the correlation between embryo loss and the high THI value. So in the summer versus the winter loss, we see 3.7 times more likely loss of embryo and 5.4 more likely if it's twins. So cow flow is defined as the annual cycle of breeding, freshening and drying of cows for the dairy. Milk production and the dairy's revenue, cash flow are directly impacted by the cow flow. So impact of cow flow influenced by heat stress include, but are not limited to, cow flow for transition facilities, cow density in milking parlors, overstocking in the calf facility if they all calve at once, reproductive performance, strained cash flow, and overall cash flow. So to put it in a summary, what we see is reduced dry matter intake, the colostrum quality, but also milk quality in general, and colostrum volume, are all reduced when in transition cow experiences heat stress. Not only that, but birth weights are low due to shorter gestation periods. Cows also experience an increase of displacement, abomasum rates, ketosis, metritis, retained placenta, and edema when transitioning. Heat stress also influences the milk production. So as previously mentioned, dry matter intake decreases, energy is diverted from milk production and reproduction to heat abatement. Mid and late beta cows are slow to recover to pre-stress production levels, and the peak milk quality is lost from the earlier occasion. And last, but definitely not least, heat stress reduces the feed quality as it gets wet and hot from the feed release sprinklers, which reduce efficiency and consumption. It simply becomes less appetizing. We also see other issues. We see increased prevalence of manure and slurry in the alleys, which we mentioned earlier. As a result, we see more lower lac contamination and other splash. And therefore, we see a high bacterial load for the powder prep to remove, which in turn can cause mastitis in the cows. So my second last slide is this one. So additional health issues influenced by heat stress include, but are not limited to, increased laminitis, lameness from reduced laying time, and more walking and standing on concrete floors. Acidosis, induced laminitis, which in turn can turn into culling and death, and increased summer pneumonia rates, especially with calves. But I don't want to end on this note, so let's move on. To end on a happy note, there are plenty of solutions that we can provide and improve the cow comfort to reduce milk drop during hot days, preserve milk quantity and quality, and ensure that both the mother and calf are fit and healthy during the warm summer days. So this farm is a farm I visited last year in northern Germany, both in the spring and in the autumn. And they decided to install these fans somewhere in the second half of the summer. And the effects were immediately noticeable. So not just comparing to the first half of the summer, but especially to the year before, when they could compare the data in the computer and they could see, okay, this is what it was last year, and now we see what it was here this year. So last but not least, no farm is the same. No barn is the same, on the same farm even. Ventilation is not a commodity and requires careful planning for the optimal result. So cow comfort, but especially ventilation and cooling, is not a luxury. And you may have heard me say it before. It is vital for the herd health. It will save money with an excellent ROI. We can measure what it can do and give you quite a good prediction of how much money you will save and how much it takes to return the investment. And with that, I'm done.
Perfect. Thank you so much, Peter. We do have a few questions, but just a reminder to everyone, if you have questions, please type them into the Q&A box on the bottom of your screen. So Peter, the first question is, do you see ventilation practices changing over the next decade?
I do, yes. I sincerely do. I see that, especially in Europe, I think we'll see changes. So heat stress is not something new. This has been around for years already, and farmers have already seen the need for ventilation. But as I mentioned before, it is not a commodity, and just by hanging up a few fans in the barn, you solve the issue, or at least not always. And you can actually save money and install less fans, but install it correctly to do it right. So on the picture on the screen, you can see that these fans are at an angle of 30 degrees. So they blow downwards to where the cows are. I've been on beautiful farms where you walk in the feed alley and you feel this nice breeze, and you think, oh, this is great. But then if you walk into the cubicles and you go down and you measure the wind speed at cow level, there's hardly any movement. And in fact, it doesn't smell so nice anymore. So what I think is going to happen, we will see more and more focus on where the ventilation should be and where the ventilation is pointing to. So it shouldn't be pointing vertically, so outwards. It should be pointing down to where the cows are. And there'll be more focus on the quality of ventilation, I think, and also on the positioning of the fans. Absolutely.
So you showed some examples. If you're walking throughout the barn and you may see some behaviors that cows are exhibiting that indicate that they are in heat stress. Is there a way that you can floor this behavior to say that a certain percent are experiencing heat stress?
Well, I think it differs per farm. The group you should be most concerned about, in my view, is the dry cows, especially the cows close towards calving. Studies have shown that a dry cow in heat stress during calving has a massive effect on the calf for up to 3 generations afterwards. So that's a risk group that we should always look at carefully. And high yielding cows is another group we should always look at. So if it's dry cows, especially the late dry cows and the high yielding cows, if they're struggling, then we have an issue.
How can we optimize the old ventilation in a barn and give an opinion for changing the type of ventilation to horizontal or vertical?
So what I've done a few times already in the past is, instead of replacing the fans, I try to give them a new purpose. So if you see what you've seen a lot, especially in Europe, and I'm sorry focusing on Europe because that's where I'm from. You saw all these panel fans that they used and they sold for the last 10, 15 years. They still can work quite well. They're normally not efficient for where the cows are laying down, but you can still use them, for example, at the feed lane. So we can reuse them at the feed lane, and then we can use, for example, the ECP fans that you see on the picture, where the cows are laying down. Because basically what we want the cows to lay down. It's when a cow lays down, she's producing a milk. She's chewing her cud, she's content, and that's when the milk's being produced. So sure, we can make changes but still use the old system.
Do you have any suggestions for ventilation in the rotary parlor and the holding area?
Yeah, that's a good question. Especially the holding area is where cows are bunched up together, and they're normally very stressed because they have to be close to dominant cows. They don't always like to be there. So cooling in the collecting yard or the waiting area, whatever you want to call it, is hugely important. And that's where we put a lot more focus on cooling, but also in the rotary or any parlor for that matter. We want to make sure that the cows are content when they're being milked, free of flies, which ventilation does as a byproduct, and not just getting fresh air and cooling. And also, we want the cow to go back to the barn without being heat stressed. So she'll be comfortable. Normally, go to the feed lane, have something to eat, ideally with some ventilation, and then go down to her favorite place with the most cooling, which is the cubicles or whatever she wants to lay down. But yeah, the collecting yard, waiting area, parlor, hugely important for cooling. Absolutely.
What are some easy to implement tips for trying to reduce heat stress on your farm with maybe spending a little bit less money?
Sure. Ventilation, of course, is ideal, but you can already take steps in other ways. So you can insulate the roof. Roof insulation has a huge effect on the radiation of heat into the barn. You can provide shade, and this could simply be done with some cloth, some dark cloth, keeping the sun out, keeping the radiation out. Other things you can do is open doors, open windows, let fresh air in. You can use soaking, making the cows wet. But be careful with soaking. It should be a system where it doesn't drip down to the side and onto the other. You don't want that. You just want it to cover the back, but make the drops big enough so the water goes into the fur and onto the skin, so the heat can radiate out through the water and not create a sauna effect with small droplets where you just insulate the fur. So yeah, there's a lot of things you can do with heat abatement, helping the cow get rid of the extra heat, or preferably preventing the cows getting too warm in the first place, even without proper ventilation.
We have a question on the picture that you have on the screen showing a louvered fan. And what is the difference between a fan with louvers compared to a more traditional panel style fan?
I'm so glad you asked, because there's lots of differences. So air is like water, and water always chooses the path of least resistance. And what we want to do with the air that comes out of the fan is stop the movement, because since the fan turns, the air that comes out of the fan is also turning and keeps moving. And with this turning air, you lose some of the efficiency. Now, we also lose some efficiency with putting these louvers in, but we also gain a lot from these. So what we do with these louvers, we create layers of air, one above the other. And we point the first layer very much downwards as much as we can, almost vertical, and then gradually we move them up. So in this case, this is a 70-inch or 1.8 meter diameter fan. This fan can reach 16 to 18 meters in length, with a wind speed of minimum 2 meters per second. The louvers, what they do, they create layers of air, and the first layer may hit an obstacle. This could be a cubicle or a cow standing up. And normally that would stop the wind completely in its track, and it will just disperse and be gone. But with these louvers, the second layer will say, no, keep going. And it continues. And the third layer is the same, and the fourth is the same. And it goes on and on and on, all the way to the end where you reach 16, 18 meters. And you make sure that the air keeps moving. In addition, and this is just physics, the diameter of the fan, in this case 1.8 meter, let's say 2 meters to make it easy, will eventually get a width, effective width, of about 3 times the diameter. So in this case, 5.5 up to 3 meters, up to 6 meters wide, which is perfect for head-to-head cubicles. So that's why we prefer to use these fans in these situations.
What are your suggestions for using high pressure fogging or sprinklers or droplets for cooling?
Sure. So those two are very different. When we talk about sprinklers, we're talking about directly cooling the cow itself. And as I mentioned, we do this carefully, so we only wet the back of the cow. We don't want the water to go down the sides. We want to use big, heavy droplets, so it enters the fur and flattens the fur up all the way to the skin. So we create a conductivity So the skin can release the heat through the wet fur out in the air. And we normally use this in combination with high-speed fans, which help evaporate the wet fur and create a cooling effect like sweating does. High pressure fogging is not to cool the cows. It's used to cool the ambient air. And by doing that, by creating cooler ambient air, we help cool the cow indirectly. The issue with high pressure fogging, which works very well, don't get me wrong, but especially in Northern Europe and even further south, it doesn't work very well when humidity is very high. So if the humidity is, let's say, over 60%, and there's no room, there's no space in the air to absorb the moisture and evaporate the droplets, the small droplets, to cool the air down. And basically what you're creating is a sauna, and you make it the reverse effect. Now you want to avoid that. The other thing I want to say about high pressure fogging is high pressure fogging normally works better in a closed environment. So in a tunnel ventilator barn, where you control the air, you control the airflow, you control the airspeed. High pressure fogging works a lot better because if you, for example, take this barn, which you see in the picture, and you use high pressure fogging, you're spending a lot of time and energy and water creating cooler ambient air, and with a little bit of side breeze through the windows, that cool air is moved within seconds outside, and it has no effect on the air inside the barn. So it works best in dry climates, high pressure fogging that is, and especially with buildings where the side walls at least are closed or can be closed with curtains, so you can control where the ambient air, the cooled ambient air is going. Soaking will work almost anywhere.
Another question on the ECV louvered fans that are on the screen. Is there a certain angle that they should be hung on, or is it okay to have them positioned directly down onto the stalls?
So normally, when we want to, cool the cows which are in cubicles, we want to hang the fan at about 30 degrees. It doesn't matter if it's 32 or 28, it's fine. But 30 degrees is what these fans are built for, and the louvers are also designed for. When we go to a collecting yard, we tend to cool even more aggressive, and we don't allow for the space in between the fans. So we can have up to 3 fans in a span of maybe 50 meters, and then we tend to hang the fan even at a steeper angle at maybe 10 or 15 degrees. So to push the air further down towards the cow. So yeah, at VES-Artex, we like to use the term ACE, as in champ, but ACE stands for animal-centered environment. And what this refers to is we want to cool the cow, not the building. And the ECV fan, which you see here hanging on these chains, is exactly what it does. It's pointing at the cows and it cools the cow, which is the whole key.
All right, I think that is it for questions. So thank you everyone who joined us and for all of the interactions. And Peter, very much for being our webinar speaker today. If you want to go to the next slide, Peter. We just want to invite everyone to our next webinar, which will be held on May 11th at 11 a.m. Central Time. Dr. Mario Manneke will be speaking on a very interesting topic on your barn is not that special, and that is okay. So we very much would invite you to join us. With that, I think we are good to wrap up, and we hope everyone has a good rest of the day or evening, depending where you are in the world. Thank you.
Thank you.